Okay, people, what is the y-intercept? Well, if x is 0, it's -4. Great. X-intercept, well, we let y be 0, and we're going to solve this little cubic equation. So I think I'm going to divide throughout by 2. I don't know about you. That's a lot easier. And then let's test values. So maybe what we can do is we can try x is equal to, what about, say, -1? Let's see if that works. -1 cubed minus 3 times -1 minus 2 is -1 plus 3 minus 2, which is 0. Great. So then x plus 1 equals 0 is your factor. So let's have a look at this. We've got our cubic, x cubed, don't forget the 0x squared, minus 3x minus 2. And we put our little factor there, and this gives us x squared times x is x cubed, don't forget the mx, and then minus 2 over 1 is minus 2. So that gives us our little brackets there, our smiley face. There we go. 1x squared plus mx squared is going to be 0x squared. Remember, put that 0 in for if the x squared term's not there. So it's 1 plus m is equal to 0, so m is equal to -1. So if we then plonk in the -1 there, it's x squared minus 1x minus 2, and we proceed to factorize. Now look, it's x plus 1, so it's x minus 2, x plus 1 equals 0. Now look at this. This is brilliant because you've got a repeated x-intercept there, or x equals 2. So we've got our x-intercepts. And you'll notice from the previous one, do you remember that this is almost a turning point if it's repeated? Now have a look at this, the gradients. Let's put we've got fx is equal to, what's it? It's x cubed, or 2. Let's go to the original. I think it's important that we work with the original. In terms of the graph, what was the original? It's 2x cubed minus 6x minus 4. Always work with the original. The derivative is 6x squared minus 6. Put that equal to 0, and you got 6x squared minus 6. Now, if you then divide throughout by 6, you get x squared is minus 1, so 1 is equal to x squared, x is equal to plus or minus 1. Now let's work out the corresponding y values. The f of 1 go into the original, 2 times 1 cubed, minus 6 times 1 minus 4, 2 minus 6, -4, minus 4 is -8. And then what is the f of -1? Let's plug in there and see what we get. Well, it's 2 times -1 cubed, minus 6 times -1, subtract 4, -2 plus 6 minus 4 is 0. So you've got a turning point at 1, -8, and -1, 0. That's a turning point. Interesting. It's where the repeated x-intercept lies. Okay, now let's draw the graph. Okay, and then we'll do the point of inflection in a moment. Okay, so if we put that there, where's our little grid? Here we go. So what was the, let's go back and check. The y-intercept was -4. Great. Okay, so that was -4. So we can go down here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So the y-intercept is 1, 2, 3, -4 there. What are the x-intercepts? The x-intercepts -1. I won't be 2 to scale, and 2. So it's -1 and 2. And remember, the shape is like that because that the coefficient of x cubed is, of course, very, very positive there. You can see. Okay. Very positive. Good. Okay, now, in fact, you can even look at this. That's where it's positive. Okay, now, then we've got our turning points at -1, 0. So it's going to turn here. So it must be turning, must have a maximum there. And then a minimum at the other one, which is going to be, if you look at that, the other one is, we've got, yeah, the f of 1 is -8. Sorry, there we go. I just got a bit stuck there. So f of 1, okay, is -8. So we go down here. F1 down at 1, we go down to -8 there. Okay, got a little bit lost there for a while. Okay, doesn't matter. But now this graph goes up, turns, cuts at -4 there, comes down and turns at 1, -8, and up we go, cutting the x-axis at 2. And you'll probably agree with me that that's a turning point. So when you get a repeated x-intercept, there's a repeated x-intercept, what do you notice? That the graph turns there as well. Okay, now stay with us. We're going to do more cubic functions in the next lesson.